Alright, so this is the IO list, input or output list for the system. First, soil moisture, temperature sensor, and humidity potentiometer, which are acting as the analog input with the range of 0 to 123. And the function is to read the value of the environmental condition and also to regulate the environmental parameters such as the soil moisture, the temperature, and also humidity level. Also, we have DC motor that act as train in this simulation. It is digital output with the range of high and low. DC motor for drain is activate irrigation based on soil moisture level, while DC motor that act as fan also digital output with the range of high and low that simulate air circulation for temperature control. And here we have micro servo that act as a roof with the type for this output is PWM with the range of 0 degree to 180 degree. It operates the motorized roof to close during rain and open it during dry condition. So move on to the next output, which is red LED, blue LED, and also green LED. All of these three type colors of LEDs digital output with the range of high and low with fixed value. The unit is logic level. Their function are as a visual indicators for high temperature, low temperature, and also normal temperature. While we have yellow LED that act as a visual indicator for water pump. Also digital output with the range of high and low. We also do have buzzer that is digital output with the range of high and low. With the unit is frequency. The buzzer will sound and alarm when high rain and humidity are detected. Last but not least, we have LCD of 16 times 2 inch with I2C communication. The type is I2C with the range of 0 to 5 volt. The function is to display real-time temperature, humidity, and soil moisture.
Okay, so first we will start the simulation by turning on the Arduino. So when you first start the simulation, it will show that on the LCD that the soil is 0, the humidity is also 0%, which shows that it is in dry soil right now. So to start the simulation, we will first simulate the regulate the temperature. So now it is at 25 degrees, which is under standard conditions. So if we go up above 25 degrees, it will show that the red LED is turned on, which indicates that it is very high temperature. In that case, the DC fan, which is our fail-safe system for the ventilation, will turn on, which will then regulate the temperature to standard conditions. Next, we will then regulate back the temperature to below 15 degrees. When the temperature is below 15 degrees, the blue LED will turn on, and then the fan will turn off, which shows that it is below standard conditions, and it will turn off the fan so that it could regulate its temperature again. But if the temperature is within 15 to 25 degrees, which is around 20 degrees, it will show that the LED is green, which means that it is under standard conditions. Next, we will simulate the soil moisture sensor. Since the soil moisture sensor is now 0, the yellow LED will turn on, which means that the soil is very dry and it will pump water into the greenhouse system. But if we simulate the soil moisture system to around this area, it will show that on the LCD that the soil is 118 level, which means that it is dry soil. So since it is dry, the water will still continue to pump until the moisture regulates. But if we go in between 300 to 700 levels, it will show that the system is indeed in humid conditions, which means that it is in good conditions, and then the yellow LED will turn off, which indicates that it is in standard conditions. But if the soil moisture sensor is around full, which is around 876%, it shows that the system is now in water and it is in flooding. So after that, the DC motor will turn on, which shows that the fail-safe system is working, which will work to drain out the water. Next, we will also simulate the potentiometer, which is for the humidity levels. So if the humidity levels is around here, it will show that it is around 30%, which is still acceptable for soil conditions. And if we just go above a bit higher, which is 100% humidity, the buzzer which is for the warning system, will turn on. But this condition will only work if the humidity level is 100% and the servo moisture sensor is also 100%. So that if the humidity levels is full, the warning buzzer will turn on and then the servo motor will turn on, which is also one of our failsafe system, which is the roof system. So if it if both conditions are fulfilled, the warning buzzer will turn on and then the failsafe system, which is for the roof, will also turn on to prevent water from entering the greenhouse system. So that is all for our simulation. I hope that this video will explain good enough for our Tinkercad simulation. Thank you.
Let's move on to the code explanation. For the first part of the code, we start with the library of the LCD and the servo, then follow up by defining the function of the LCD and the servo. We then follow up the code with setting up the pins, where blue is 2, green is 3, and so on. We then code to define the temperature for the high temperature threshold and the low temperature threshold, which will then can be used to light up the bulbs or the LEDs. For the setup, we start the code with serial begin and then follow up by setting up the LCD. We then define the pins for the servo and defining the types of pin for the input pins, which are the temperature sensor, the soil moisture, and the humidity sensor. We also follow up the code by with defining the output sensors or the output components, which are the LEDs and the motors and the buzzers. So for the next part of the code, which is the loop resets for every 1000 milliseconds, which equals to 1 second. So in the loop, there is the calculation for the soil value, which equals to the analog read of the soil moisture sensor. There is also the temperature value, which reads the value of the temperature from the temperature sensor, which is then being calculated into the actual temperature reading. And there is also the humidity value, which gets the humidity value from the analog read of the humidity sensor. This, which is simulated by the potentiometer. The humidity value is then being calculated as humidity, where the value ranges from 0 to 100%. This is then followed by the display of the LCD, where the LCD will display the value of the soil moisture and the humidity percentage. So for the next part of the loop is the if-else statement. So firstly is the soil value. When the soil value is less than 300, the LCD will print dry soil. This means that the pump LED will be turned on, and this simulates that the water pump is being turned on. And when the soil value is in between 300 and 700, the LCD will print humid. This will signals that the soil is humid, and then the pump LED will turn off. And if the soil value is more than 700, the LCD will print in water. This signals that there is too much water content in the soil, and the pump LED is turned off, followed by the drain pin being turned on. Inside the soil value being more than 700, there is another if else condition, which is being used by the humidity sensor. If the humidity sensor sense that there is more than 90% humidity, followed by the soil value being more than 700, the buzzer will be turned on and the servo will turn anti-clockwise. And when the condition is returning back to normal, the buzzer will be turned off, followed by the servo will turn clockwise, which means that the servo signals that the servo simulates the opening and the closing of the roof. So this is the final part of the loop, which is another if-else statement. But this time this is for the temperature condition. When the temperature is lower than the temperature low, the blue LED will be turned on, whereas the green and red LED will be turned off. The command for the fan pin, which is the ventilation, is also being turned off. When the temperature is in between the temperature low and the temperature high, the blue LED will be turned off, whereas the green LED will be turned on. But the red LED is still turned off, and the fan pin is turned off. And the final condition, which is the temperature being more than the temperature high, the blue and green LED will be turned off, and the red LED will be turned on. This will signals that the temperature is high and the ventilation will be turned on, which indicates by the fan pin high.
To conclude our project, the automated smart greenhouse system is efficiently maintain the optimal condition for the plant growth by monitoring the soil, moisture, temperature, and humidity. Its automated irrigation, ventilation, and alerts while incorporating with a rainfall system to prevent the flooding. The real-time monitoring on the LCD are ensure the awareness of the user and the Arduino who know best to control demonstrate the effective integration of sensor and actuator. This project showcases practical and scalable solution for the sustainable agriculture and in unpredictable climates, for example, in Malaysia.